I've received your email address, alejo15@gmail.com.
Let's go. Perfect transcription, baby. Oh my god, this is so cool. You know what kills me? Spending weeks building the perfect voice agent, nailing the personality, the flow, the integrations, and then client calls and says, it got my email wrong. And here's the thing, the conversation could be flawless, but if the information didn't make it to their CRM, none of that matters. I used to obsess over transcription accuracy, but information capture and transcription accuracy are not the same thing. So in this video, I'm sharing with you our 4-level framework for perfect information capture. And level 4 guarantees 100% accuracy. And we just showcased it in a workshop in our community. So today I'm not only showing you the complete system, but at the end of the video, I'm also sharing with you a glimpse into the future of transcription. Because I just spent time with the leaders of the transcription startups in San Francisco. What's coming next blew my mind. So here's everything you're going to get today. Level 1 focuses on the native settings in platforms like retail that most people aren't really using correctly. And level 2 is what I call the data scientist method that shifts information capture to post-call analysis of the transcript using a data set, for example, of addresses or emails in order to interpret what's in the transcript. So even if the address was transcribed incorrectly, we can fix that after the call. Level 3 is more of an enterprise solution, and it builds on the first 2 levels. So you run multiple transcribers simultaneously and then use consensus voting to catch errors. And then level 4, which is my favorite, the breakthrough human-in-the-loop approach from a startup called Poku that guarantees 100% accuracy on information capture. Addresses, emails, names, anything you want to capture. I'll also cover the multilingual pitfall and what's coming with the new Flux model from DeepGram. And by the end of this video, you'll know exactly which level your use case demands. Real quick, I'm Alejo from Amplify Voice, and I've been banging my head against the wall since I started building voice agents about 2 years ago. Because if LLMs have gotten that much better and voice generation has gotten that much more real, why is transcription still not working like it should? I've been meaning to do this video for a really long time, and now we finally have the right framework that I can share with you that you can fit to your use case. And the 100% guaranteed information capture actually comes from a workshop that we did in our school community. So if you're building voice agents, my passion is breakthroughs. My passion is innovation. So I'm sharing all that new information, and I'm sharing everything that I've learned through these live workshops and inviting other people from startups and other agencies to show how they build better agents and sell them to businesses. So if that sounds like something you're interested in, come check out the school community, links are below. Now let's get into the video. Level 1 for increasing accuracy is using the settings that are already in the platform that you use. In this case, we'll find them under real-time transcription settings. We'll have 4 options to tweak. Number 1, denoising mode. The first option that is selected by default is the better transcription accuracy. If you choose to also remove background noise, then transcription accuracy will go down. That's why it's so important, as I always say, know your use case, know who you're going to be talking to. If most of the conversations happen in a car with screaming kids in the back, then yeah, you would want to remove background speech. But if this is not necessary with your client's audience, then just keep the remove noise. Then transcription mode. The default is optimizing for speed, but you can also optimize for accuracy. The trade-off is that the transcription model is going to be slower, about 200 milliseconds slower. And what it essentially does is it sends more information to the transcriber, which keeps previous context in the sentence. Then, if you're using a medical use case, then you would want to select the medical. Otherwise, just keep it general. And then boosted keywords. What this does, essentially, you can pass in a set of keywords that are more easily recognized by the transcriber. For example, the company name, or the names of towns and cities around the business location. But then the second way to use these boosted keywords works especially well when you are doing outbound calls and you have information about this user. For example, the user's first name. And you can actually use dynamic variables with boosted keywords. The user's company name, or any other information you have about them. My only warning is don't do too much here. Just use variables that you would actually be relevant in the conversation and could come up. just to make sure they are transcribed correctly. If you do too much here, then the model can start getting confused and transcribing other things that weren't supposed to be transcribed as any of these words. Usually you shouldn't need more than 2 or 3 boosted keywords. And these can be phrases, like a company name with several words. Now finally, one of the big pitfalls for transcription is when people choose multilingual. This makes the agent way more flexible, but everything becomes worse. Transcription is worse. The LLM can get confused if the transcriber thinks that the language changed, and voice generation is also more inconsistent. The way to avoid this issue is a trade-off, like any of these settings, is choosing the most likely language, and be aware that there are several English types: India, UK, Australia, New Zealand, and US, and then asking the user which language they would like to continue with. If your client wants to limit it to 3 main languages, let's say they're in the UK, so they also want to include Spanish from Spain and German, then you can have a main agent that asks the user which language they would like to continue with, English, German, or Spanish, and then you can have a function for agent transfer. And this agent transfer function can transfer to any other agent, like the same agent, but for German or for Spanish. Or if they decide, let's continue in English, then the conversation just continues. It doesn't need to change to any other agent. If you're curious about agent transfer and other functions, I did do a whole video on how every single one of these functions works and how to use them more effectively so they trigger when they're supposed to trigger and they do the right thing. I'll leave the video linked above and below in the description. Now that's all for level 1. Let's step into level 2, which is not for improving accuracy during the call, but improving the information capture after the call ends. This is what I call the data scientist method, and I want to give a shout out to Giannis, who inspired this method with a video that he made about a year ago. I've iterated on this method a bit to make it more dynamic and not only capture emails, but any other piece of information like addresses. Or for medical use cases, it could be medications. We have this very small but very powerful N8N workflow. This would be a part of the end of call report, where it's making sure that it can extract the email correctly. So we're gonna plug this into the agent using the webhook, production URL. I changed, obviously, the HTTP method is a post, and then we're responding immediately. We're going to our retail agent, and down in webhook settings, we plug that in there. And I'm just telling this agent roleplay and ask for my email address. And before I do the demo, there are 2 caveats here. Number 1, for weird last names like mine, Pijuan, the agent's very unlikely to get it right. It gets my name, Alejo, right, because obviously there are several examples of the word Alejo. So the transcriber, does just fine. Weird last names, very, very hard. Practically speaking, ask the user to spell out their email. Transcribers are still going to have issue. Information extraction is still very hard, even when the email is spelled out. But it's better than nothing. And caveat number 2 is sometimes in some use cases, you know the name and last name of the person, you just don't know their email. So if you have that information, leverage it. So you can pass it along before the call begins as a dynamic variable, and you can use it in the end of call report to help this AI agent transcribe the email correctly. So now let's give this agent a test. Okay. Hey, how's it going?
Hey, I'm doing well. Thanks for asking. How about you? By the way, could you please share your email address with me?
Yeah, it's alejo15@gmail.com.
Okay, so I received the end of call report. It's pinned right here with the transcript and all that stuff. Alejo15@gmail.com. Awesome. You see that obviously it has the 15 instead of the number, and then G space mail. So we want to fix that. Hopefully the agent got that done. The only thing is, you're going to go into use case configuration. If you have a different use case, this is where you go in and change it. Data type. Are you looking for zip codes? If so, from which country? So we're going to give out examples. I'm going to show you what you would modify for different use cases, apart only from email addresses. This transcript, though, we're going to drag and drop the transcript from the webhook right there. Okay? And now it has the transcript. It has a bunch of patterns, validation rules, and what we want. The output key, which is, well, we want emails. Now we're gonna rerun this, now that it has the transcript, and we're gonna see the output. And let me walk you through this problem real quick. So it's essentially extracting key information. What is this information? Well, again, it can be anything. Emails, zip codes, addresses. We're giving the transcript. We're giving it some speech patterns, like what is the pattern for a zip code in Ireland is very, very different than a zip code in the US. So we want to give it that those patterns, some validation rules, like a zip code should have 5 alphanumeric digits or 6, and it's spelled this way, and first goes this and then goes that. So some validation rules. In our example, we're using for email. When people spell out email during phone calls, they typically say this, instead of that, instead of that. In this case, we have the Gmail example, G space mail instead of Gmail. And then we have the task, extract the email address in this case. And here are some examples. You receive this is the transcript, and this should be your output. So the reference text, where is the email, expressed? And then what is the right email? What is the predicted correct email? It can also include nothing. Sometimes there might not be an email. You don't want an output, so it can output nothing. The way you go and modify this, especially these examples, everything else are variables. You can modify it in the set node. But these examples, you would want to go to Claude and it's like, hey, my use case is zip codes in Ireland, so adapt the examples and the output. So in this case, we have the reference text, alejo15@gspacemail.com, and it provided the correct output that I expected, which is Alejo with numbers 15. So now we plug this into the CRM, we're golden. If you want to take this to one extra level, there's this application, there's this website called Reune, Email Verifier. They have some lifetime deals that you can get like 100,000 emails verified. They're not a sponsor, but you can do an HTTP call and essentially, hey, does this email exist? And if it doesn't, then you can go into level 3, which I'm about to show you. So if level 2 is any use case where bad data is a lost opportunity, like a lost lead, level 3 really focuses on high stakes environments where errors have consequences like medical, legal, financial. You can't mess up the transcription of a medication. So not only would you use boosted keywords, for example, but sometimes boosted keywords is not enough or not possible. So level 2 is fine, but if at high stakes, we want consensus. Consensus from what? Retail uses the dgram transcriber, but there are other transcribers out there. For example, Assembly is an incredibly accurate transcriber. It's just kind of slow for real-time transcription during a phone call. But if this is the end of call report, then we don't really care about latency. So we're going to use the original transcription, then the assembly transcription with the recording, and then the Whisper transcription from OpenAI. Whisper allows for what's called transcription with prompting. So you can give it some hints about what this transcript is going to be about. There's going to be these terms involved, say medical terms. You're going to be capturing an email. These little tiny one-sentence prompts will help this transcription model transcribe better. And then we will create a consensus. What did each transcriber say that the email was? And if at least 2 of them agree, then we'll take that as a true email. But if all 3 transcribers disagree, then we can, for example, send it to a human. Again, these are critical use cases where we can't really fail. For large enough companies, this can be the responsibility of an assigned human to check calls where maybe there was too much background noise or there were multiple voices at the same time. So this is what that implementation looks like. We have the original transcriber, which comes from the webhook, that's level 2. I'm going to move this here so we have access to the original transcript. Then we have the 2 other transcribers, Assembly and OpenAI Whisper with prompting. So in the configuration, we're going to have the audio URL, which we're going to pull from retail. We have recording URL. We're going to be using the multi-channel one. And then the whisper prompt, I'm going to change this. This is a call with a user, and they are sharing their email. This is the importance of understanding your use case, understanding your audience. The more specific you can be with this prompt, like giving company names. And it looks something like this. Common terms to keep in mind are amplify voice, voice AI agents. If you tell it the industry, it can also help. So we're going to keep this generic so you have this fuel and you can adapt it to your use case. And then you can go get an API key from Assembly, API key from OpenAI, and ideally add it as a credential. That's what I did. I'm not going to paste API keys here. So once that configuration is done, you'll see there are 2 Assembly API calls. One submits the recording, and it'll start working on it in the background. So we have a wait node, which in this case, I wait for 2 minutes. If your calls are really long, then you might want to increase this. Again, we're not on a time crunch, ideally, right after the call ends. Or you can reduce it if your calls are really fast. And then we get the result after the transcription is done. So we're just getting that transcript ID. Lovely. So we're going to see it in action in a second. And for the other transcriber, which is OpenAI Whisper, we need to download the file first. And then we pass along that file, which we're going to plug in here in a second. And what we're sending to OpenAI is the file, which we're about to get, the type of model. Then we have the whisper prompt that I showed you just now in the configuration.
And then the response format, which is what we wanted in JSON.
So let's see this in action. I'm going to click on download file, and I just have to give it the right file to download.
Okay, so we're actually choosing NADM binary file instead of form data. That actually took me an hour to figure out, so you're welcome, I guess. Very frustrating, but we got it.
So I'm going to execute this in a second because Assembly just finished executing. We're getting the transcript, bam, and then, cool. So that took, a couple minutes waiting, but we're good.
And now let's execute this. And then I'm going to show you how to put everything together, which this is the fun part. This is what I've been waiting for.
So while this is processing, let me explain where we're going with this.
We have now 3 transcripts: the original transcript, the Assembly transcript, and the OpenAI Whisper transcript.
Right here, boom. Now the objective is putting it all together. How do we actually compare whether this was right, which it was, or the Assembly one was right, or the original one was right? Well, we're gonna put the things together. We're gonna grab this agent,
and we're gonna bring it to level 3, because with the new transcripts, now we want new data extracted. We're gonna put this use case configuration, which is for you to adapt. We're gonna put it right here at the beginning.
What does this mean? That now we have the transcript passing along, the original transcript passing along.
Then we're gonna connect it to this.
So we're gonna go through path 1, then path 2, and we have path 3, which is the original one.
So I'm gonna grab this agent and I'm gonna triplicate it. Essentially, we got 1, we got 2, we got 3.
So one of them is gonna go through the top agent, then one of them through here, and then the other one, the original one, through here. Okay, so now everything's plugged in. We have the original transcript from DeepGram. We have the second transcript from Assembly, and then the third transcript from Whisper. Let's execute this workflow with the previous call and see it in action. So while this is running, which is going to take a couple minutes, I want to create the consensus mechanism. And this is what that consensus analysis agent looks like. We're connecting the 3 pieces of data.
This ran, so I'm pinning it. Okay.
And we're saying, here are 3 outputs from other LLMs that you need to compare. If at least 2 out of 3 outputs are the same, output the common one using the following JSON formatting, which we're essentially checking, is there a match? And then consensus output, which is what was the output that matched. If none of the outputs match, then return false with the consensus output empty. I'm actually going to change this, John. Okay, awesome. Cool. So we have an example of what the consensus output should be. If you're using it for a different use case, just make sure you change this as well. And I actually just realized we're going to need a merge node instead of passing straight in. This is going to be 3 outputs that we need. and we're gonna append them to each other. Bam. Okay, so we're gonna merge it in. Okay, so now we merged and combined all of the outputs, and this is what we get. It's each output from each LLM. I see that there are 2 matches here, so the consensus agent should match as well. And now that we run the consensus agent, it should match as well. I should obviously show you that this is how I'm putting the inputs. Okay, awesome. Now that that is done, let's see. It outputs true, and that the consensus output is alejo15@gmail.com. Okay, so what if this is true? Or what if this is false? Well, let me show you how to make this data actually actionable. If this is false, if there is no match, in this case I'm doing a send message and wait for response to Slack. You can put the recording URL in there for a human to review and for example, write back, oh, this is, exactly what the user said. So then we can keep going. If this is true, we can connect our CRM, upload the data, upload the contact, fill in the fields that we need to fill. So let's say we connect our CRM, let's say Soho CRM, we create a contact, lovely. And then once we get this response from a human, we would just plug that in there because we would have the right email now. Is this your flow? Is this your client's flow? Maybe, maybe not. The point is that now you have as close to perfect transcription as possible. And even a human in the loop component when you need that extra level of accuracy. I am afraid to inform you that this is still not 100%. There's gonna be edge cases, there's gonna be situations where 2 people are speaking so loud that you can't hear the user's email, even a human. And actually, the hint to perfect transcription, 100% transcription, lies here in the human in the loop. So let's jump back to retail so I can show you level 4. Level 4 is actually a product that a startup called Poku created. It's pokulabs.com. This is what we built yesterday during the workshop, and this is Poku Labs. They are not a sponsor of this video. I just sound like an ad for them because I really, really like what they're doing. I think that human in the loop is the future of AI because it's not about separating AI from the rest of the company. It's about integrating it. And they have several different things, several different types of human in the loop systems. The one that we're going to be touching on today is their two-way SMS tool. So we're going to go to the dashboard, and it's very easy. It's very quick to create an account. You're going to generate an API key. Then you go in human in the loop, and essentially what we can do is ask the user. This is going to be a two-way SMS, and this is what it sounds like. Let's give this agent a call. Hello.
Hello? I'll need to collect your email address. You can reply to the text I just sent you with your email. Would you like to do that?
Yeah, sounds good.
Perfect. I'm sending you a text message right now where you can reply with your email address. Thank you. I've received your email address. Alejo15@gmail.com.
Let's go. Perfect transcription, baby. Oh my god, this is so cool. Great job, Emil and Christina. This is really, really sick. So we skip all the hoops. We don't we don't have to do this. You can do this. There's some situations where people can't really be texting. That's why it's so important to understand your client, understand your use case, understand your audience. Who are you going to be talking to? And where level 3 is this extreme level of accuracy, it's still not perfect. It might fit some use cases though, much better than the Poku solution would. But in my opinion, in the majority of use cases for voice AI, the text me this information real quick, your name and email, it's a lot smoother because of the level of accuracy. So 100% of accuracy with the user having to, text a couple words, in my opinion, beats having to create this whole thing, plus the cost of running this whole thing. And if you're not sure what is the right solution for you, then put it in the comments. I answer every single comment. If you have a use case that I haven't mentioned that maybe doesn't fit any of the solutions, I'd love to explore with you what is the right solution for you. And to me, your biggest win is that now when one of your clients asks, hey, so can we capture the emails? You can confidently say, yes, we can capture the emails. It used to be really hard and really inaccurate.
And now it's 100% accurate depending on the solution that you go for.
And it promised you a glimpse into the future of transcription. So let's recap this, and then I can show you where it all connects. Level 1 is tweaking these settings. We have the real-time transcription settings. You can tweak them depending on your use case. Level number 2 is what we call the data scientist method, where we're giving this data set of emails of bad transcriptions and how they should be changed according to the input. Essentially, how do you write an email correctly? Then level 3 builds on that method to use different transcribers to hear different things. In this case, assembly was the one that was off, but the other two were correct. Alejo15@gmail.com. So we have that consensus agent that says there is a match, and it's Alejo15@gmail.com. Then we get into level 4, which is 100% accuracy as long as the user can type, which is using the Poco Labs two-way SMS to send an SMS asking for some information, receiving it back, and integrating into the AI agent. Poco also have some other tools, not only the two-way SMS, but also contact human to ask a question. Like there's a question outside the knowledge base, and it can text or call a human to get that information and relay that back to the user immediately, notify a human of some information, flag a chat for review, or add several numbers that you would want to call. So there's going to be, I'm sure, a future video where I dig deeper into Poco. But now let's get into something that I wouldn't really call level 5, because now we're starting to get into a categorically different type of transcriber. What do I mean? What I mean is DeepGram just released their new model called Flux. And this model doesn't only just grab audio and generate words, it's a little bit further. It interprets the tone, because hello is not the same as hello, and excuse me is not the same as excuse me. And I got a chance to sit down with Scott Stevenson, the founder of DeepGram, and get a little bit more insight. I'll definitely share this blog post with you, but I want to summarize why Flux is so revolutionary as a transcriber in 2 things. Number 1, turn taking for real-time agents suddenly becomes a lot more effective, because this model is no longer only transcribing words, it's also transcribing the tonality that a human uses when finishing a sentence. Which brings me to benefit number 2, which is then latency can be a lot faster, because the model guessing when the user is done speaking is now way more effective. So the latency between turn and turn, between the user speaking and then the agent speaking, is a lot more smooth. And this is the graph that he showed that really did it for me, which is this precision versus latency. And up in the blue is the new DeepGram Flux model. At the bottom, then you have the metric of latency, and then on the left you have the precision. So the higher up, the better precision it is. And you can see that at every latency or size of the model, Flux is the best at precision of transcription. And this is huge. DeepGram has been ahead of the game for a really long time. It is such a pleasure to share this with you, because you might not be a transcription nerd like I am, but I hope that you see the impact that this is going to have in our ability to create better voice agents. And you now have a 4-level framework to not only increase transcription accuracy, but perfect information capture. And if you're curious where you can get that NNA scenario that I created for you, it's all built. You just have to change the API keys. Click on the school link below. It'll take you to the resource that you can download and plug straight into your NNA. And if you're not yet a member of the school community, you can go get the free trial, go to the classroom, and get the scenario for yourself. Right here in YouTube resources is where you can get it. but also have 4 live sessions a week. We're going to add a 5th one in the future where we're building together, we're troubleshooting together, we're bringing specialists from all different areas of the voice AI industry, and we also teach you how to sell. Because there's a big gap between knowing how to build a voice agent and knowing how to build a business out of it. I'm excited to meet you, I'm excited to be part of your progress, and remember to never stop prompting.